Hello, everyone. Welcome back. Hope you're having a great day so far. You are in the right place. This is the Encode Layer Hackathon, and we are in our next kind of workshop, part of the workshop series during this hack. Today, we have a great speaker from AltLater joining us, and it's going to be on kind of AltLayer in general, as well as kind of what is their Flash layer, as well as what they're kind of looking for in the hackathon. If you haven't registered for the hackathon quite yet, you still can. I will post a few links there that you can register, and then as well as some additional resources to look into AltLayer and kind of the Flash layer challenge here. But without further ado, I'll introduce our speaker, Jimmy Chu. He is a blockchain engineer at AltResearch. He's going to be hosting us and have our amazing workshop today. Thanks for joining us, Jimmy. We'll pass it over to you for the workshop.
Yeah, and thank you, Steve, for introducing me and having me here, sharing our work with you guys. So I'll just share my screen. Okay. All right. So I'm Jimmy, and I am in the ecosystem development in AltResearch, and I'll introduce about like what we have been doing, and then what problems we're trying to solve, and first of all, give an introductions of what our products are, what are they trying to do, and then some examples that we have been doing, and something that we are looking for from the hackathon submission entries from you guys. All right. All right. So what kind of problems that we see when we are working on this project, right? Okay. Meanwhile, I'll try to also take a look at the chat box and see. Oh, okay, it's from Steve. All right. Yeah. You guys feel free to, because I know you guys are muted. So if you have any questions, I'll also at the same time looking at the chat box. So just type there, and then I'll try to address them when as soon as possible after I finish the a sections there. All right. So the problem that we see and we're trying to solve is actually is common in both layer 1 and layer 2s right now, is that like there have been like different scenarios that it will cause the traffics to spike up in the blockchains, and then that will affect the whole user experience, both in terms of the times to get finalized for their transactions. Sometimes you would like when the time that is really congested, you see that your transaction doesn't go through. It takes a long time. And secondly, it's about the transaction fee that you experience. So just within this half a year, right? We see that in April. This is a tweet that we collected is from the other deeds. They are doing an NFT sales, because it is quite popular, right? For this NFT campaign. So there are like the price of the whole transactions got spiked up during that time, and cumulatively we see that there are over 200 ETH are being burned during this campaign. So each users are pretty much spending about 2 to 3 ETH there in the gas fee alone, like each users. So that is quite a fee there. So this is happening on L1, and then the second story that we see is it is actually happening on Polygon. So Polygon is a side chain that is already trying to address the aforementioned problems that we see, like in terms of scalability, in terms of having a faster finalized time, and having a cheapest fee here. But that same things also happen on polygons. So polygons under accidental attacks from another like blockchain games, Sunflowers Farmers. The game is it's kind of getting some tractions, and then it's quite popular, so that it's become consuming pretty much the like over 40% of all the transactions during that time. So Sunflowers game consuming, occupying pretty much about 40% of the transaction during that time. And so not only it affect the game of Sunflower itself, but it also affect all the other dApps running on polygons. So the fact that one dApp becoming popular is not only affecting its own, but it's also affecting the experience of other dApps on the same blockchain. That is another issue that we see here in this story. So it created the external negative externalities for users on other dApps. So this is the second story of the same problems, right? Now the third story, right? This is happening on Arbitrum. So Arbitrum is another layer 2 that is also trying to solve the problems of like scalabilities, having the high transaction fees. And at that time, this happening at around, I think it's around June or May or June. So that is in their version 1 of Arbitrum. And then they also have an NFT mint campaign as calling Arbitrum Odyssey. So during this campaign, again, because of the congestions, they have to pause the whole campaign in the middle. And the gas fee on Arbitrum was higher. And it actually, eventually, the gas fee become higher than that on the Ethereum L1. So we have been seeing that the problems of having like when within a short amount of time there's a traffic happens, we like a lot of traffic happening within that short amount of time, we see that the gas fee will suddenly spike up, and it also affect the transaction fee. It also affect the transaction time. So these problems actually happen not only in blockchain, but it has happened before. If say when in like 10 or 20 years ago, it is also happening on the web 2.0 sphere, and then that is when the cloud infrastructure as a service happened. Like, so they come up with the idea of like renting out their cloud service providers, so that people can scale out their service on their data center. When they see that there's like the Christmas time come, and then they are already foreseeing that the websites will have a heavy traffic, people will go to these like cloud solution provider. They will scale out their service and they get to handle more traffics. And then when the seasonal traffics swing down, right, after the Christmas time, so they'll scale in back their resources, and this way to handle the spiked traffic. So we are thinking if we could apply the similar approach in block space, in blockchain, and that's what we are trying to do in ALtLayer. So our proposition for ALtLayer is that first of all, we have a very fast block time. It is almost near instant, like we have 2 seconds of a block time, so it's almost instant. You get an instant finality when you are doing deploying a dApps here. And we are also having like we have tested and having about 2,500 transactions per second, and that is our layer 2, and it supports multiple kind of virtual machines. So the most famous one being the EVM, so that you could also you could deploy Solidity smart contracts on ALtLayer. But at the same time, we also support Varsums. So far, we have tested substrate runtime, so that if you are substrate is another kind of L1 blockchain. So if you are building substrate runtime, you can compile the Varsums and then also have it run on our layer 2 blockchain. And the fourth one is what we have been mentioning, is about that it is disposable, so that it could optimize your resources. So it's disposable, meaning that when you foresee that the traffic will spike up, for example, when you are running a round of like a NFT mint campaign, or you are running a round of like a blockchain games, so you can foresee that the traffic will be very heavy during that period, so that you can launch your applications on on ALtLayers. Then once it is done, you can roll back up all the states that's happening on the L2 back to your chosen L1. Currently, we support different kind of EVM chain, such as, of course, Ethereum, and also on the Polygon, right? And so it's powered by the so we use optimistic rollup methodologies there. So why we are building ALtLayer, right? Because we see that the shared block space model is not ideal for most popular dApps. So the shared block space is meaning that the same blockchain is running different kind of dApps. But as we mentioned just now in the previous story, is that one popular blockchain app could also actually create some effect on other blockchains, dApps running there. So we are thinking if we could offer an L2, a layer 2 blockchain that first of all, you can roll it up back to the L1. And secondly, it is fast, it is cheap. And thirdly, it is app dedicated, meaning that you could have a blockchain that's only running your own dApps so that you are not affected by others' dApps. It is just all your own block space. And then you run your transactions there. And then when you're done, then you just roll it up back up to the chosen L1. Okay, so that is what we are trying to build here, ALtLayer. And currently we are offering two product offerings, pretty much under the same technology. One is called a short-lived application dedicated rollup. We call it a flash layer. And then the second one is more a persistent application dedicated rollup. So we will cover that in the next page here. So on flash layer, this is the short-lived application tailored rollup. We also have the fault proof here. So I'll just go through like what is a flash layer about. We can take a look at the diagram at the bottom below here. So at the beginning, a project owner would see that, okay, he foresee that he will be doing some kind of NFT mint event or at some kind of event that he foresee the traffic will spike up, so that he's originally on L1, right? Like for example, Ethereum mainnet, and then he decided to deploy his smart contracts and also to bridge some of his assets, whether it's the native chain tokens or ERC20 tokens, over to the flash layer. And then he deployed the contracts, deployed the bridge assets, and he will publicize this L2 smart contract address, and also have the front end interacting with these smart contracts on the L2. Then people will do their stuff here on flash layer. Maybe they mint the tokens, and then they have run different kind of games, so that all the execution happening on the L2. And finally, when the campaign is done or when the game is finished for that round, we have the technology to roll up all the states back, all the states and the transactions back to the L1. And finally, he could decide to dispose the resources there. And so this is a whole walkthrough of how a flash layer is happening. All right, and that is, so again, what is it ideal for? It is ideal for, say, minting event when you are doing airdrops at certain period of times, and also running, like hosting a game. We actually have an example. So we actually hosted a Dark Forest game, a game of Dark Forest. It is a kind of like a Galaxy Conquest player versus player game in real time. So I'll share more later, like how it goes. So this is flash layer, and then the next one. Oh, okay. So this is like why doing flash layers for NFT. So again, you see that there's fast deployment. There's no gas war, meaning that like others people transaction will not affect the transaction fee for your dApps interactions. It supports different kind of chain. And then you could have dedicated block space. And it also, the assets could either the assets could be distributed on L1 or L2, but eventually you could always roll up the state to L1. And finally, the UX would be similar, meaning that whether your users, for your users, it will be using the MetaMask or the wallet that they have been familiar with. And for your developer, they will be using the same set of tools. Say, for example, using Hardhat and using Ether to deploy their smart contracts and then to test their developments there. So it will be the similar tool set, both for users and for the developer. So this is the Flash layer. And now, just now we talk about the short-lived dedicated app dedicated blockchain, the Flash layer. And then now we are talking about pretty much the same technology underneath, but then we are talking about like a persistent layer 2 blockchains. So this is also app dedicated, but you could imagine that like they would probably be some kind of like long running the apps there. For example, you could say if you are running a DeFi exchange, or if you are running some kind of like a long running blockchain game, you would want to have a persistent layer 2 like blockchains, and then roll up to layer 1 from time to time. So this is what is target to do. So looking at this diagram, right, the whole life cycle, again, we see that the blockchain owners or the blockchains, the project owners would want to initiate the whole smart contracts and everything on the L2. And then from time to time that you see that it can roll up the transactions and the states back to the L1 with our also have the fraud proof technology there. And but just that you won't like finally dispose the chain, but you will just keep it running. So it suits for two kind of like pretty much it is to address two different kind of users or teams for our blockchain there. So let's get a little deeper to our architecture here. So I won't go too deep about like how the technologies is going, because on one hand we are also still building it, so that may change in the future, and also I don't want to make this too technical this time. I want to give an overview of what is happening underneath, and also there are something that we are still building and not released yet. For example, one of the things that we are building is, you would see in here that because you could see it is disposable, you would expect that there is some kind of a dashboard or so what we are building right now is a dashboard, so that you could easily deploy your own dedicated like your blockchain layer 2 blockchain there, similar to like when you're using a cloud service provider, you would have an interface, a dashboard to deploy the cloud and then also provision the cloud. So this is something we are working on. In these hackathons, you guys will be working on a Flash layer that we have been deployed there already. So later in this workshop, I'll also try to demonstrate about using interacting with that DevNets here. So it is a Flash layer that we have deployed for you guys, and then it is free and it is ready for you guys to use. So first of all, there is this. We'll go from the left to right, right? So the user interact. So the users have a MetaMask wallet connecting to our endpoints, and then it will send a transactions to this network. The transaction is actually sitting in the transaction pool. And then we have a component called aggregator, and this aggregator will assign an order to these transactions. Yeah. So once we have given the order to these transactions, it go to our block producers. The block producer is pretty much the one that is producing and maintaining the layer 2 blockchains. Yeah, so it supports multiple virtual machines, so the EVM and the bosoms, and so it based on the transactions it create the states, and eventually generating the blockchains here. And then we have the third component here, which is called the verifiers. The verifiers are actually outside of the layer 2, outside of the block producers. So they're listening to the events happening on the blockchains and listening to the blocks that are being emitted from the block producers, and then they'll try to verify on this block if they are if they have the right Merkle, if they have the right proof, and finally, after the verifier verified it, okay, they see that the block is valid, and then they will submit it back to the L1 to the layer 1. So this is how the whole process of from user submitting the transactions to the layer 2 to our endpoints, and then what is happening on the block producers, and finally how there is a verifier to verifying transactions and finally submit it back to the layer 1. All right. So there's the like an overview of the architectures. So with this architecture, right, you can see there are different level of finalities here. You're talking about. First of all, there is one finality that will be being determined in block producers level. So this means that when the block producers have included transactions inside the blocks and then generated the next state of the next state, so that is one level of finalities here. So one honest block producer has generated the correct blocks, and then the next level of finality is the verifiers, which is like it is like someone monitoring what is happening on the blocks and then doing an audit on the transaction, on the what is happening on the block L2 blockchain, right? So the verifiers are monitoring the blocks, and then they pick up what is happening on the chains, and then they verify the transactions there. So if the verifiers also endorse the transactions, that is another level of finalities there. And so when they endorse it, they will sign what is generated by the block producers and finally submit it back to the layer 1. And layer 1 will treat it as, so we will treat the layer 1 as the ultimate finality. So because layer 1 is an Ethereum or whatever other blockchains, right? We have the smart contracts running there, and if the layer 1s also compute the state transitions, computing the transaction, and then getting the same results, also included in their block, so we say that is the finality on the rollup level, and that is also the finality provided by the layer 1. So this will be the ultimate finalities. But of course, like the higher the security that you choose, the faster that it is you'll get the result back, or the faster that you have to wait. But then it's kind of like the less secure. So there is different kind of security levels that you can pick. Depends. So it is kind of like a trade-off. Like if you want it to have a fast response, you probably have a less securities, or otherwise you can wait all the way to getting the finality from the layer 1. But then in this case, you probably have to wait a little bit longer. So different kind of securities promise and for developer to choose for. All right, so I see a questions from Nisa Ahmed. Is the transaction pool is where user transactions go or user interact with aggregators. And so you are talking about this. So the users actually interact with the aggregator, and then inside the aggregators, the user submit the transactions, and then the transactions, like when the user submit the transactions there, like they cannot determine the sequence. They cannot determine the sequence. The sequence is actually determined by the aggregator here, right? And finally, with the sequence determined, and then they are sent over to the block producers. So the user are interacting with the aggregators there. And so you could say that the aggregators, like the power of the aggregators is only determining the order of the sequence, but they cannot tamper. They cannot tamper with the data inside the transactions, because the transaction has already been signed by the users. So like if they change a bit, the whole hash and also the data will not be consistent. So that's that is so that's what the power of aggregator, meaning like what they can do, pretty much like determining a sequence, but and what they cannot do, which is like manipulating or tampering with the data within the transaction from the users. All right, so I'll go through some examples of what we have been running on ALtLayer. So we have been doing our own minting. Like since we discussed about, like we mentioned about, we see that there are a few NFT mint events that is spiking up the fees and also affecting the finalizing time. So we hosted a POAP style mint event. We are issuing 400 NFT, but then we realized that so with that mint event, we announced it beforehand, and then the users have to do some like simple actions, for example, like following our Twitter, and also probably leaving an email address, something like this, and then finally we will whitelist them and then give them an account, so that they can mint the NFT event, and it is gasless. And the 400 NFT is minted within 18 seconds, and we have configured our chain so that it has 0 gas fee. You could say that with 0 gas fee, like it is possible that people will come and have like causing some kind of like DDoS attack. So that's why we also have some rate limiting checks there. And we also see that the NFT mint actually only lasts less than a minute. We realize. So with 400 NFT and with done in 18 seconds, so it eventually average out to be happening, processing about 50 transactions per second at this time. And the whole transaction cost, like pretty much the whole like all the gas fees total to about 0.25 ETH on our mint. And finally, they are all rolled back up to the to Ethereum, and then now they are listed in the OpenSea. All right, so this is an NFT minting events we have conducted before to kind of like test run our chain. How is it going? And secondly, we have also hosted a game called Dark Forest. So it is space conquest type of a game, real-time strategy game, and it lasts for 2 days. Yeah, it lasts for 2 days, and within the 2 days, we actually see that about 1900 so 190k transactions are actually happening, and that turns out to be about like 94k transactions. And but during that times we see we don't see any gas fee spike happening on our blockchains. And then we are processing about 94K transactions per second. And that is, which is like that kind of like transactions throughput is about like approximately 60% of the transaction throughput of all the Arbitrum dApps there, and 90% of the transactions of optimism. So imagine that suddenly, if you are running these games on Arbitrum, you are creating an extra 60% of the total transactions during those periods there by running game. So that's why we see that our like the ALtLayers is actually really suitable for running like kind of like the games, blockchain games or dApps games. All right. So that's the second example that we have run, and now it come to the hackathons that you guys are like you guys are apply for, right? So it is happening. It has already started from October 17th, and on November 30th to November 13th, we will have our engineers to look into all the applications from you guys. So I hope that you will take advantage of these opportunities and also try out using our ALtLayers. So there's a hacker pack in this link, which I believe like Steve has already posted, and if you haven't registered, so please register, right? So what we are looking for, we see, so as I mentioned just now, that we see that like if you can foresee any kind of activities or apps that will causing a sudden spike on the traffics, those type of application will be really suitable to deploy or to be deployed on ALtLayer. So NFT related dApps would be so. Blockchain game components would also be something that we see could easily create a traffic spike. So these two type of like these two verticals are something that we are especially looking into. And then we also see that something that is lacking is like Oracle like dApp that's providing some kind of source of truth. It is lacking in the industry. We see that like something like is it Chainlink? Yeah, it is kind of is doing that, and also some kind of component that facilitate the graph query on ALtLayer would be something great for the whole development, like for all the developers in ALtLayers or even in the blockchain. So some kind of component that facilitate graph query. All right, so I see some questions, so let me address them. What are some product statement and requirement you are specifically looking for? So we don't have like specific requirements that we are looking for. It is pretty open. As long as it is dApps, so it definitely have to have the smart contract side. And then we hope to have also have some front end that interact with. You can show us a demo, and that's pretty much about it. And if when you are also developing for ALtLayer, right? Just as I mentioned just now, is if you could take advantage of like your dApps could cause some kind of traffic spike, and then ALtLayer would be ideal for handling such kind of dApps that even in those traffic spikes, it won't affect the fees and also the finalizing times, and it also doesn't affect other dApps on the chains. Of course, right now, because it is the one of the dev nets that we have deployed, so that every submission is sharing the same sharing the same block space in this case. But eventually, with our dashboards being released, you will have a chance to deploy your own specific dApps, your own specific flash layers there. And especially for NFT DApps, I'm not sure if you want yet another NFT marketplace. Yes, NFT marketplace probably won't cost a traffic in won't cause a traffic spike, unless you guys have some kind of like flash sales, or some kind of bidding and auctions. So because usually in the auctions, depends on how the auction mechanism is, right? Usually at the last moment, or at the last probably the last minute or last 5 minutes of the auctions, the traffic will spike up, and then people will start to bid seriously. So depend on your auction mechanisms. For some kind of auction, you may want to try to also leverage on layer 2. And another thing is probably if there are some kind of tools that you could switch seamlessly between an L1 and also ALtLayers, that would be great. That it doesn't affect the user, like the user that is using the DApps probably won't realize that because due to the traffics that that set of the underlying smart contracts has been redeployed to the layer 2, and then their connection is redirected to layer 2 in order to have a good user experience. So that kind of tools that kind of abstract out the users experience, but then it covered but underneath, actually they are doing kind of like the switching between the layer 1 and the layer 2. So that kind of tools could also be proved to be useful as well. All right, so this is what we are looking for on the hackathon, and I want to demonstrate a little bit of how the DevNet is behaving right now. So I'll come back to this to my browser, and I have the MetaMask. So the first thing we need to do is to add our endpoint so that your MetaMask could interact with it. So I have Arbitrum test Goerli. I want to add a new network, right? First of all, there's some documentation link here. Please click on it, and on the first document, you'll see the alpha DevNet informations here. So we will have a MetaMask connect to the DevNet, and then we will get some test tokens from our faucets. And finally, you will also I'll also show you the block our block explorer, and finally I'll do a bridge transactions. So from the Goerli test network to bridge some test tokens over to our DevNet. This is the endpoint information. So from the MetaMask, the network name AltLayer DevNet. Oh, this is the endpoint, and chain ID 9990. Oops, 0. And because this is a DevNet, so let's use DALT, and the block explorer URL is this. So with this, we are now connected to the AltLayer DevNets, and I will go to the. So now we can go to the faucets. We have added that, and first I'll go to the faucets first to get some test token. Here is the faucets, and I would copy my own address. So that's ALtLayer and 10 alt tokens. Submitted, and then let's wait for a while. Okay, now the 10 testing token arrived. And then we could check out our, this is the faucet. We could check out, now we could check out the block scout, which is our block explorer here, the DevNet block explorer. This is also all documented in this DevNet info page here. I just switched the order here. I get the test token first from faucets, and then I'll show you about our block explorer here. And now we can take a look at my just now the wallet address that I have. You can see, so the finality and the block time is 2 seconds. And if we select this address, you can see there are 10 alt coins, and that transactions happened just a minute ago from this smart contracts, and then sending the transactions to me. All right, so you have the block explorer, there's a faucet, and finally I want to demonstrate about the bridging here. So the bridgings is here. Let me reload the page. It is, I should be using this. This is the address that I showed just now. And this address, I don't have any gears. Probably I don't have any gears, do I? Nope. So I'll also need to get some test tokens of ETH on Goerli. Oops, alchemy of soul. So let's try this. So hopefully I'll get some test token in a minute. No, I'm just switching over the network. So right now we have the bridge connected only between Goerli and our DevNets, but it support all kind of EVM chains. So we could also connect it to Polygons or to Avalanche. Yeah. And we also have the roadmap to also support other kind of L1 chains. So that include the Solana, also Polkadot in futures. But that is in our that will be in our future roadmaps. And our current priority would be to launch the dashboard so that our developers could deploy their own dedicated flash layer. Okay, so we see that there is 0.1 GF. Let me see if so there's a 0.1. But it is not updating. I wonder if okay, so it is sending 0.04 Goerli if network is busy, gas prices are high. Okay. So this, so there are a few transactions happening, right? One is on one hand is happening on Goerli side. It has to confirm on the Goerli, and then finally we have the bridge, and it will send some requests to the on the ALtLayer. So it will on the other side minting the new tokens there. But I wonder if I opening that again. So it is in progress. So it seems that on the Goerli side, it has completed, and on the AltDevNet side, we are. How are we doing? This is the native tokens. And this is probably some things we need to look into is on, so what's going on the AltLayer sides. Well, yeah. So eventually, once this part is fixed, you would see that the amount is deducted on Goerli side, and then the amount will increase it on the AltDevNet side. Two bets. But so that's how the bridge is currently working. We'll take a look into what's going on underneath afterwards. But let me show, like in here we have a screen cap of a successful bridging transactions. Is on one hand that is being deducted, and finally the amount is being increased, being minted on the other sides. So that is the bridge. But eventually, when you want to develop the your DApps, right? you can take a look at this repository. I believe most of you are probably familiar with Hardhat for developing the smart contracts DApp. This one is a simple repository, but we already have the runtime. We already have the endpoint configured so that it connect to both the Goerli and our ALtDevNet here. You just need to configure the .env to have. If you are using Alchemy for your for connecting to Goerli, you'll have your Alchemy API here, and then set your whatever private keys, and that will be the accounts for deploying the smart contracts. And running these Hardhats examples, running like the run deployed, you can deploy the simple smart contracts. You can deploy the smart contracts on DevNet here, right? And here there's a sample ERC20 tokens here, pretty much derived it from the open siblings. All right, so this is about the demonstration on the ALtLayer. Yep, and all the documentations are actually like in the link here and also in this page. So you guys please try that out and start working on and start the deploying of the apps on ALtLayers. Meanwhile, I'll go back to take a look at what's going on the bridge transaction there. Yep, that's about it. That's about the demonstration and the presentations for me today. Any questions you have?
Hi, Jimmy. Nisar here.
Right.
The one of the thing that I'm very new to all of this. I have been reading from last 3 to 4 days many things. Right? So one of the things when I was reading through Metis is also part of this discussing about the EVM equivalence, and when I've discussed reading through ALtLayer, it says it is compatible for EVM and WASM. Okay. Is it something? Is it also like equivalent EVM equivalence where the same contracts can be deployed on this network as well, or is my question completely wrong?
Yes, that is EVM equivalence. Because we pretty when you run the smart contracts on, because we pretty much treat the EVM in Ethereum, right? The EVM in Ethereum as a canonical EVM, and our EVM is pretty much the same. It generates the same results as the EVM in the Ethereums, so it is EVM equivalence. So that's also the meaning of if it is EVM equivalent or not. Basically, using your EVM to run your set of transactions, does it result in does it generate the same results as running it on the Ethereum? And in our case, yes, it is.
Okay. The flash layer that you discussed and explained about, if something which is very for less time and then something which is persistent, right? So this is also kind of a set of nodes that are created at runtime whenever there is a flash is created, which has its own dedicated storage as well. And how is it guaranteed that the flash layer is there, like before it concludes the transaction, rolls up to L1? How is that guaranteed? Like from an architecture perspective, just trying to understand.
Oh, okay. So when at the time when you trigger to deploy a flash layer, right? We will be running a few nodes for you, and then you can also have your team running the nodes and also engage your community to run the nodes. So that will be the kind of the validators running the nodes for the flash layers. And then eventually when you roll up, and then when you roll up, So it is just a bunch of transactions being written over to L1. And then when you dispose the chains, it means that we will dispose all the chain informations on our side. And then if the nodes are not managed by us, you will also have to coordinate those nodes to be disposed as well. But we see that usually if it is a short-lived app dedicated chains, usually it will be enough that the project teams and we our side also are doing hosting the nodes will be enough. It is usually more of the long-term persistent chain that you would want to engage your communities and your validator community to run their own nodes for it to be like highly decentralized.
There's one last maybe I don't know what is graph query. When you mention facilitating graph query, can you just briefly explain or point me to where I can understand what exactly is expected from? I'm coming from Web 2 world, so Web 3 world, when they say graph query, so for us it is different. So where can I understand what is graph query when you say facilitating graph query?
Oh, probably you already understand about the GraphQL.
Yeah.
Yeah. So you are using GraphQL to query some kind of database, right? And then it generates a results back. So the whole blockchains can act as you could see a blockchain is actually a bunch of a distributed database that different kind of people, all the validators or nodes validator are keeping a copy of that database. But right now it is hard to build up the relationships on the blockchains. Like if the data have different kind of relationships or having some kind of like key and also the key value relationships, it's kind of hard to set up that kind of like entity relationships on blockchains. So that there's a project called Subgraph, the graph.coms. Just showing the front page is you will build up some kind of like interface so that you can issue the GraphQL and then you retrieve back the result from the blockchain.
Okay.
Yeah, instead of like directly sending a command to read the blockchain, to read the smart contract storage, you're sending a GraphQL and then you retrieve a set of results. But that like data entity relationship has to be done by the developers. Has to be done by the developers using the GraphQL. So that there's a layer. The developers that will have to define the data entity relationship there. How the smart contract storage will map back to the data entity relationship. So that's graph about like GraphQL, the graph query on blockchains. I'll conclude it at here. Meanwhile, I'll also be in the Discord groups in Encode. And also we actually have a Discord group as well, like in our Discord servers. So you could also join. You could also join us on it. Let me post the link here as well.
Yeah, please, reach out with questions about the hack in our Discord. If you're having trouble finding that, please let me know. You can ping me directly on Discord, and I can kind of navigate there. As Jimmy's saying, he'll post kind of AltLayer specific Discord as well, with any questions throughout. I posted a lot of information upcoming, but our next workshop will be next Tuesday, same time, 4 p.m. GMT, October 25th. It will be with AltLayer again. Rollup as a service and why it matters to the next gen of D apps. Very great session again there. So please look out for that. I posted a link register below if you haven't. But with that being said, thanks for coming with your questions and being engaged. And big thanks to AltLayer and Jimmy at Alt Research for putting on this amazing workshop today. Thanks so much for joining us, as I know it might be a little later your time. So thanks again, Jimmy.
Thank you, everyone, for joining me here. Yep.
Bye-bye. Thanks, everyone.
Bye.